So in this video, we're just going to look more formally at the process for determining the time constant of an RC or RL circuit when there's one reactive component, meaning a capacitor or an inductor, but there are multiple resistors. The key point is, as we've seen beforehand, that tau is still equal to the equivalent resistance times the capacitance value, but everything we've worked so far is relatively simple. The question is, how do you compute REQ? And the key point is it's the resistance seen by the capacitor. So you're basically asking yourself, what is the resistance measured from the top of the capacitor to the bottom? So in this case, note that any current that leaves the top of the capacitor has to pass through R2. So R2 is in series. Once it gets to this node, it can branch either through R1 or R3. So R1 and R3 are in parallel. So the equivalent resistance with respect to the capacitor is R2 plus the parallel combination of R1 and R3. Remember, when you have only two resistors, the easiest way to do parallel combinations is product over sum. So that's how they're getting this R2 plus R1 times R3 over quantity R1 plus R3. In this example, we have an inductor. Again, we can find the equivalent time constant by simply finding the equivalent resistance, and it's always going to be from the actual perspective of the inductor. So and it doesn't matter which side you pick. Like, you can pick this side or you can pick this side. Let's pick this side on the left and ask how current returns to the inductor on the right. So it has to go through R3. So it's going to be R3 plus, R3 is in series. Then it can branch through R1 or R2. So R1 and R2 are in parallel. So it's R3 plus R1 parallel R2. And then once it sums back together at this node, it has to go through R4. So the two things that are going to get added in series are R3 plus R4, and then you're going to have R1 and R2 in parallel. And that's exactly what this says, only they've written R1 and R2 in parallel in terms of the product over the sum rule. So the main point of that video is just to remind you, when you're computing the equivalent resistance for a time constant, make sure to do it from the perspective of the reactive component.